Hi, this is a video where I'm going to do an example of calculating frequency using wavelength and the speed of light. We're also going to calculate wavelength, and then we will eventually calculate energy of a wave. So first question, example I'm going to do with you is we're going to calculate the frequency of the bright red light that we get from doing a flame test with lithium. The wavelength of that red wave is 700 nanometers, and this is part of the electromagnetic spectrum, so it's going to travel at the speed of light. So in this question we're solving for frequency, which we do use the Greek letter nu to represent. And our equation is the speed of light equals wavelength times frequency. So then we can just sub in our speed of light. And then we do need to, before we can sub in, we would want to convert the nanometers into meters. And I know that there's 10 to the 9th nanometers in 1 meter. So I could take my 700 and I'm going to multiply by 1 over 10 to the 9th. So really, my wavelength in meters is 7 times 10 to the negative 7th meter. So now I can plug that in over here, and then I'm going to be solving for nu, which is frequency. So I would divide both sides by that wavelength. And you can see my units cancel. This completely goes. So I end up with 1 over second, or inverse second, which is also a hertz. So ultimately my answer is 4.3 10 to the 14th, and you could give that as 1 over second, or inverse second, or hertz. The next example, we're going to calculate the wavelength of the radio station that we have, 101.3. And the unit is, it's in megahertz. So we are going to need to convert that. So we know our frequency of that radio wave is in megahertz. And we know that there's 1 times 10 to the 6th hertz in 1 megahertz. So really, we're talking about a frequency of 1.013 times 10 to the 8th hertz. So then I can use my equation. I know the speed of light, and I'm going to solve for wavelength. So I would put my speed of light in equals wavelength times the frequency. And I'm going to write it as 1 over second, because then you can see when I divide, my seconds will cancel. And I'm solving for wavelength, so it's going to be in a distance unit and it's going to be in meter. So once I do this, I should get 2.96 meters. And then the last question, we're going to look at a wave that has a frequency of 1.5 times 10 to the 15th hertz. And it is traveling at the speed of light. So we're going to calculate the wavelength first. So to get the wavelength, we would plug in. Again, I'm going to write hertz as 1 over second, and then divide both sides by 10 to the 1.5 10 to the 15th. So then I get my wavelength My seconds cancel, I'm in meters. Wavelength here ends up being 2 times 10 to the negative 7th meter. I can also calculate energy. So energy is going to equal Planck's constant, which is 6.63 times 10 to the negative 34th joules times seconds. It's going to equal that times the frequency of the wave. So if I plug in Planck's constant, and it's joule times second, and I multiply that by the frequency in this question, I'm going to write it as 1/2 to show you that the seconds cancel. You end up with that energy unit of joule. So when I do this, I will get 9.95 times 10 to the negative 19th joule.